A very good day to you. My name is Uma Mageshwari Saravanan. Today, I would like to present my proposed project entitled Development of Visible Light Active Crystalline Carbon Nitrate for Photocatalytic Degradation of Microplastics. The proposed product is highly recommended as it would help reduce the microplastic pollutants based on the photocatalytic oxidation method. The crystalline carbon nitrate (CN), which has been acknowledged as a promising photocatalyst in the removal of organic pollutants, will be used to investigate its effectiveness in the degradation of microplastic. The crystalline CN will be modified with the red dopant to extend its light harvesting to an extended visible light region due to the sunlight consisting of 45% of visible light with a wavelength of up to 700 nanometers. This project is highly recommended as it satisfies three Sustainable Development Goals (SDGs), which aim to have a better health, clean water, and especially to preserve marine life. Why this project has the potential to be commercialized? First, the conventional approach uses biological and chemical processes, which has several drawbacks such as a high cost, consumption of time, and formation of side product. This project is highly commercialized based on these four factors, which will be discussed in this presentation. Our project has two main objectives, which are firstly to create a photocatalytic reactor that uses crystalline carbon nitrate to break down microplastic from environment like seawater. And secondly, to design this proposed reactor to be affordable and easy to use. This project addresses three main problem statements. Firstly, microplastics, which are tiny plastics found in ocean and seas today, pose health risk to both human and marine life. Scientists have found this microplastic in all parts of the body, including the lungs and stomach. Second, the current methods for removing microplastics, like chemical and biological processes such as biofilm and absorption, are costly and create harmful byproducts. Lastly, the crystalline CN materials have a great photocatalytic performance but are proven to only absorb light in the 400 to 500 nanometers range. To improve their effectiveness, it is recommended to extend their light absorption to 600 to 700 nanometers. So our proposed project can be developed with three steps. Firstly, we start with material preparation. We will prepare the CN material by adding tap to extend its light absorption to longer wavelength 600 to 700 nanometers. Then we will add potassium chloride and lithium chloride salts melt to enhance the crystallinity of CN. As a second step, we will prepare a photocatalytic reactor. We will prepare a solution with the polystyrene to stimulate seawater with microplastic. A lamp that mimics sunlight will be used for the photocatalytic test. The mechanism of how this proposed design would solve the problem could be explained via four steps, which are initiation, propagation, branching, and termination. The radiation of light will excite the electron from the valence band of crystalline CN to the conduction band of crystalline CN. The excited electron will reduce the oxygen to superoxide radicals. Meanwhile, the hydroxyl will oxidize to hydroxyl radicals. These radicals are so-called reactive oxygen species will later create the alkyl radicals. These radicals attack the polymer surface, initiate the four-step aforementioned, which are initiation, propagation, branching, and termination. Finally, cause micro crack to polymers. Eventually, the reactive species then oxidize the organic compound, turning them into harmless substances like carbon dioxide and water. This project has a potential commercialization based on these four factors. Firstly, the need. This project is crucial to tackling the issue of microplastic, which significantly impact human health and marine life. Secondly, the approach. We chose the photocatalytic oxidization method because it has several advantages over the other physical, chemical, and biological processes, which are often expensive and time consuming. Thirdly, the benefit. The photocatalytic methods offers benefit such as low cost and time efficiency, and lastly, easy preparation. Lastly, the competitor. While there are commercial products for removing microplastic like biofilm and absorption material, these are generally time consuming and costly. Finally, it is hoped that this project will help the public and health authorities in addressing the problem associated with microplastic, as the removal of microplastic is vital not only for protecting marine ecosystem but also for safeguarding human health and ensuring economic stability. Thank you.